Welcome to Brain Vision.
Question, we are given that a little bit of imaginations about the direction. So, in a region of space, there is an electric field E, and that is towards the z direction and has a magnitude which depends on x. So, that's 964 x. Find a flux for this field through a square in the xy plane at z equal to 0. It's in the xy plane with the side length of 0.35 meters, and one side of the square is along the x-axis and another side is along the y-axis. So this is the coordinate plane, and we have a square over here, which looks like this. So one side is towards the plus x-axis, and another side is towards the plus y-axis, and this is 0.35. All right. So we need to find, and the electric field is towards the plus z axis. So I'm going to point it with a cross, which means that it is going inside the plane, and inside the plane definitely means that it is perpendicular to the plane which we are seeing. All right. So we got to find the total flux, but we know that the flux is given by E dot A, but in this case the E is not constant, it's varying as the exchange. So what we're going to do is we're going to take a thin strip along a particular x. So we go on x and we take a thin strip of a width dx. This is the width dx, and we are going to assume that in this small width dx the electric field is going to be constant. So we are going to find the flux in this strip, which is going to be E dot dA. dA is the small elemental area. E is 964x. dA is, this is a rectangle, so that's going to be a length times width. So the length is 0.35 and the width is dx. So that's going to be 0.35 dx, and this is a dot product, so we have cos of the angle between them, and we know that electric field is pointing inward, and the area vector is also pointing inward or outward. So the magnitude, it can either be 0 or 180, but it doesn't really matter because cos 0 is 1 and cos 180 is -1, and we are more interested in the magnitude, so we are going to place it as cos 0. All right, so this is the elemental flux. So the total flux, let me rewrite this equation as by eliminating cos 0. So d phi is going to be 964 times 0.35. We can do that. So let me grab my calculator over here. 964 times 0.35. This is 337.4. 337.4 x dx, and this is the required elemental flux. So the total flux is going to be, we integrate both sides, and the values of x are from 0 to 0.35, and this is from 0 to 5. So that's got to be the total flux is going to be equal to 337.4, and the integration is x square over 2, and we place the limits from 0 to 0.35. So this is going to be equal to, we multiply this with 337.5 times 0.35 square over 2. So that's coming as, the total flux is coming as 20.67. So this is the required total flux through this particular square. Thank you.